can one cut stones with laser saber? How molecules are changed. If you make a molecule to explode or break on pieces with a laser or with a light, how many fragments will be created? If there are several of those, how can one find which one will be generated or in which proportions? So in the high school chemistry we had this word isomers, and if reaction creates several isomers, how do we know which of them will be generated? Ideally, it would be great to control formation of isomers by tuning the frequency or intensity of the laser and direct reaction to desired product.
And upon photoexcitation, there are several pathways. One can recombine, one can go to higher state, one can break the bond.
A little armored vehicle with a laser, and it focuses beam on the unexploded ordnance and removes it without danger to a human. So miner doesn't approach and doesn't risk his or her life. So it's explosion on a distance. One of the calculations in my group was done with help of postdoc Dr. Yulun Han. So, and also my collaborator at Polymers and Coatings, Professor Rasulev. So we take the simplest possible, one of the simplest possible explosives, tetranitromethane, like carbon in the center and NO2 groups around, and then we irradiate it. We do not do experiment. I keep my hands dry, but we model that it goes to excited ground, and when it goes to excited, it shifts, it moves, reorganizes position in space, and accumulates kinetic energy. And when we repeat the cycle, it heats up, and with time there will be hopefully enough energy to overcome the barrier and break the bond. So what if we ascend? Here is the energy, and here is the configuration. Intact molecule, elongation of bonds, and after we come to the top peak, it elongates to such distance that it doesn't recombine back anymore. And when we go down, it finally decomposes on this carbon monoxide and nitrogen oxide and nitrogen dioxide. So products, and if one goes further, their energy will be lower than energy of reactant. So it means explosion. This is not the best explosive. It's not very efficient. It just was a little guinea pig to check stuff. And the little blue and green lines show that distance from carbon to nitrogen grows rapidly and carbon to oxygen shrinks, which means bond is formed and they create intact. And the stuff on the right do show computed mass spectra formed with or without charging, injecting charge, and by illuminated at different wavelengths. And depending on these conditions, one is getting different peaks, so different products. Reaction goes in a different pathway, so we can control how to decompose a molecule on which products and experiment. So we hope by further developing of this method, of this technology, computational technology, we can predict more and more reactions and maybe do reactions that haven't been done yet on experiment to show some predictive power.